The acronym means Cross-Industry Standard Processing for Data Mining, and as the name says, it is an industry standard used to guide the data mining efforts. It consists of 6 steps. The first one is business understanding, and is the part when the analyst identifies the specific needs or goals that an organization has. And understanding the business involves identifying which problems the company has and what they want to solve. The second step is data understanding, which involves verifying and reporting the quality of data and doing exploration analysis. The third step is data preparation, which involves selecting data useful to the project, doing data cleaning, derivatives, and aggregate variables. The first step is modeling, where the analyst decides the model or the algorithm depending on the project requirements. Several models can be produced at this stage with the same data set, and all of them can be evaluated to choose the best parameter for the model refinement. The fifth step is evaluation. Usually the data are split into training and test sets, and the model built upon the training set is applied to the test set to assess its performance. Different models can be compared to assess the most suitable one. And then the last step is deployment. And once the model has been approved, it can be integrated into the organization system and can be used to forecast the new incoming data. The sequence is not one direction, and it is common to move back and forth between steps. For example, refine the data in the data preparation step after the first run of modeling. Time series are data that are indexed by equally separated time intervals, and the main goal are to identify and understand the forces that control the evolution of the data over time and to predict future values for the time series. Once the data has been checked and cleaned, the first step in time series analysis is to recognize any seasonality or trend if they are present, such as temperature variation along the day or market trends, for example. When these features are recognized, the time series can be made stationary, which is an important step since stationarity means that the process that generated the data does not change over time. To predict the future values of a time series, different models can be used, such as ARIMA model or exponential smoothing and their respective derivations. There are 4 core principles in data ethics. The first one is privacy, which means that organizations must comply with the laws and regulations that regulate the collection, storage, and the use of personal information. And the organizations must obtain consent from the person to collect and use their data. The second one is transparency, in a sense that the organization must be transparent on how they collect and use and eventually shares the data both internally and externally of the company or organization. The third one is accountability, which means that organizations are responsible for the data they collect and must take necessary steps to ensure that the privacy of the data is safeguarded. And the last one is equality, which means that organization cannot discriminate an individual or a group of individuals when handling or processing data, especially in terms of biases of the analyst that it's doing the analysis. A good practice would be to have an analysis team composed of diverse people to reduce the risk of biases of a single person affecting the work. I would firstly check the data and the model and the organization guidelines to be sure that my suspicions of bias are founded and legitimate. Ideally, I could build a different model based on the same data where I try to avoid biases that I perceive as being present. And if I have concrete evidence in the form of real numbers that the bias would affect the outcome, then I would speak with my manager. I would report the issues to the management team by pointing out the possible flaws in the measurement and modeling and suggest to check again the data measuring and modeling processes. Maybe the management team could change the guidelines for the project to limit the weight of the bias. Some ways to avoid biases could be, for example, to ensure that the observers are well trained, that the observers are screened for potential biases, specifically cultural biases, and to having clear rules and procedures in place for the experiment. And speaking of measurement errors and biases, if we are talking about measuring physical constants such as chemical compositions, physical properties, or industry machine behaviors and output, we must also check that the measuring instrumentation is in functioning order and is always calibrated. Classification models are algorithms that divide the dataset into discrete classes based on different variables. They are used to analyze discrete or binary variables to be put into classes, such as true or false, legitimate or suspicious, spam or not spam, for example. In classification models, we try to find the boundaries that divide the dataset into classes, while regression models are algorithms that find the correlation between independent and dependent variables when the variables are continuous. It is used, for example, to forecast market trends, house prices, and so on. In regression models, we try to find the function that best approximates the data, be it a line, an exponential, logarithm, or polynomial line.